Strategy for factoring quadratics of the form ax squared plus bx plus c when a is equal to 1. First, we have two sets of parentheses, and we will put an x at the beginning of each. Next, we want to find two numbers that multiply to the c value and add to the b value. Next, we place those two numbers as the second term of each factor. The first term has x, and the second term will be whatever that first number is and whatever that second number is. We can then check our answer by foiling. If a trinomial cannot be factored, then we say it is prime. For example, let's factor this trinomial. First, recognize that there is a 1 coefficient on the x squared term. You don't see it, but there is an understood 1 to be there. Now we'll do our parentheses with the x in the first term. And now we want to come up with two numbers that multiply to 6 and add to 5. If you don't see it right away, off to the side, list the factors of 6. Two numbers that multiply to 6 are 1 and 6, and then 2 and 3. Which of those add up to 5? The 2 and the 3. So we can write plus 2 and plus 3. And the order doesn't matter. You could have put 3 first and the 2 second. If we wanted to, we could then check our answer by foiling. First, outer, inner, last gives us x squared plus 5x plus 6, which is the original. We know we've factored correctly. In the next example, again, recognize that a, the leading coefficient on the x squared, is 1. So we can factor using these two parentheses, x and x. And you have to ask yourself, what two numbers multiply to -10 and add to 3? Again, if you don't see it right away, off to the side, list the possible factors. 1 and 10, 2 and 5. Those multiply to 10, but you need the product to be negative. So that means one of the numbers has to be negative, and they have to add up to a positive 3. That means the bigger number has to be the positive. So -2 and -1. Which of those pairs multiply to -10 and add to positive 3? The -2 and the 5. So in the parentheses, we have -2 and 5. Again, if you want to, you can check your answer by foiling x squared plus 5x minus 2x minus 10 gives us x squared plus 3x minus 10, which is the original. We know we have factored correctly. In this example, x squared minus 8x plus 32, we need to come up with two numbers that multiply to 32 and add up to -8. If you don't see it right away, again, list all possible pairs of numbers that multiply to 32 and add to -8. 1 times 32, 2 times 16, 4 times 8, and we want the sum to be -8. If the sum is -8 and the product is positive, that means both numbers have to be negative. And looking at all of these all multiply to positive 32, but none of them add up to -8. So it looks like we cannot factor this trinomial, which means it is said to be prime.